Okay, so now let's look at this example. So it says, suppose f of x is equal to x to the fourth minus 7x squared plus 3. What is the instantaneous rate of change of f prime at x equals 1? Okay. So here you want to pay attention to the fact it says, what's the instantaneous rate of change of f prime? Okay. So in other words, we want to make the connection that we remember that the instantaneous rate of change so the instantaneous rate of change of f at x equals 1 is the derivative at 1, right? It's the derivative of f at x equals 1, right? So here, when it says what's the instantaneous rate of change of f prime at x equals 1, that means that the instantaneous rate of change of f prime at x equals 1 is the derivative of f prime at x equals 1, which is the second derivative, f double prime. Okay, so the instantaneous rate of change of f prime of x at x equals 1 is the derivative of f prime of x at x equals 1, which is the second derivative at 1. Okay, so I'm going to just highlight these parts here so you can see it. So f, the instantaneous rate of change of f at x equals 1 is the derivative at 1. The instantaneous rate of change of f prime at x equals 1 is f double prime, or the second derivative, at 1. Okay, so you can see there what we are talking about. Okay, so you do want to make sure that now that when you're reading the instantaneous rate of change, you want to make sure, is it saying the instantaneous rate of change of our function f, or f prime, or f double prime? Because that is telling you exactly what it is. You know it's the derivative, but the derivative of what function? The original function f, or the derivative function f, or the second derivative, or the third derivative. So you do want to be paying attention to this. Okay, because now what we're going to need to do to find the instantaneous rate of change, right, just like I wrote on the second part, we need to find the second derivative and plug in 1. That's what f double prime of 1 means. So my first derivative is going to be 4x to the third minus 14x plus 0, right? Which is just 4x to the third minus 14x. So now taking the derivative of this, I get that that's going to be 12x squared minus 14, right? But I'm not done yet. I need to now plug in 1 into the second derivative function. So this is going to be 12 times 1 squared minus 14, which is 12 minus 14, which is negative 2. Okay, so this is my instantaneous rate of change of f prime at x equals 1. It's negative 2. Okay, same idea here in practice 4. It says, suppose that f of x is equal to x to the fifth plus x cubed minus 9x. What is the slope of the tangent line to the graph of f prime at x equals 0? Okay, so remember that the slope of the tangent line to the graph of f at x equals 1 is the derivative at, x equals 0, is the derivative at 0, right? So now, when I'm trying to figure out the slope of the tangent line to the graph of f prime at x equals 0, then I know it's the derivative of f prime at 0, but the derivative of f prime is f double prime, or the second derivative. Okay, so it's the same idea as I was showing you in the previous example. Again, now you want to pay attention to what our statement is asking. Is it asking us for the slope of the tangent line to the graph of f, our original function, or is it asking us for the slope of the tangent line to the graph of our first derivative function, f prime? Or it could even ask for the second derivative or the third derivative, so on and so forth. So you do want to make sure that you're paying attention to those equivalences and how to use them. Okay. So now what I want to do is compute the second derivative of my function f. But how I'm going to do that is by first computing the first derivative. So this is 5x to the fourth plus 3x squared minus 9. And so now to compute the second derivative, I just compute the derivative of the first derivative, which is 20x to the third plus 6x. Okay, but now I need to plug in 0. So I get 20, 0 cubed plus 6 times 0. So this is 0 plus 0, which is 0. And so